Hello and welcome to SoftIQ Technologies. In today's video, we will be continuing with our series, How to Customize Odoo version 18 in Windows using VS Code. The topic for today is Understanding Odoo Architecture, which is part 2 of the series. The below are the subtopics we'll be covering: Overview of Odoo's modular architecture, Core Components, Models, Views and Controllers, Addons Directory Structure Explained. We're also going to go through the database structure and the ORM layer, the role of configuration files in Odoo modules, understanding workflow of Odoo request and response, and introduction to the XML-RPC and API integrations. So the first subtopic we're going to cover is overview of the Odoo's modular architecture. So Odoo is built on a modular architecture, which means it's composed of independent and interchangeable modules. This modularity provides the following benefits: extensibility, so developers can add new features or functionalities by installing or creating modules without altering the core system. Customization, so specific business needs can be addressed by enabling or customizing only the required modules. Scalability, businesses can start small and expand functionality over time by adding modules as needed. Each module represents a specific feature or functionality, such as managing customers, that is CRM, tracking inventory, or handling accounting. The concept of apps and modules. In Odoo, modules are the building blocks of apps, and apps are collections of related modules that deliver complete functionalities. Examples include the sales app, the CRM app, the inventory app. So modules are self-contained with their own models, views, controllers, and configurations. So from our last video, we did an installation of the Circle module. But for today, we are just going to go through the basics. So basically here under apps, we can see the installed modules. Say for example, the sales module. So the sales module, or rather the sales app, has several dependencies. So if I come here and look at the created views and the created menus. So for example, maybe we can try to install one module or app. So say for example, this documents app. So if I say activate here, or even before I do that, we can look at the module information. So we can see it has all these dependencies. So the base module, the mail module, portal, web enterprise, attachment, and digest. So I'm going to activate it. So once it finishes installing, it's going to take us to the main menu. So the reason I'm doing this is to show you that we can install the documents app, and we can also uninstall it without affecting the core dependencies, because each module, or rather each app, is independent and does not affect its dependencies. So as we wait for it to install, okay, so it has installed. So for example, if we come here to the add-ons folder, and we can go to the documents app, and we can look at the manifest. So we can see here that once you install it, it has all this data that is preloaded, and also it has all the dependencies listed here. So it depends on the base, mail, portal, and such, and it has also this pre-configured data. So what we are going to do is we are going to go and uninstall it. Documents. So it's only going to uninstall the documents app. And if you go to apps, and you look for the mail module, we can just look for the base. So the base module is still installed. So let's continue. So overview of core components. So the core components of Odoo's architecture are the models, views, and controllers. They work together to handle data, present it to users, and manage interactions between the user and the backend system. So all this is also tied to the architecture we covered in our last video, from the presentation layer to the application layer, or the business logic layer, and the database layer. So this image just shows us what happens when a user request is done. So say for example a user is running a report from the browser. So a user is interacting with the views through the web browser. So what happens is a user request is sent from the views to the controller. So the controller handles the HTTP request handler, and then it does a routing of the request, which is sent to the application layer where the module, for example the sales module is. Then this is sent to the model through a query, and from the models, which is for example the sales.orderlines. Now there is what we call the ORM, or object relational mapping, that controls the communication of the model and the database. So an ORM query is sent to the ORM, which then executes an SQL query. And this ORM helps in the abstraction of the database, meaning the database is accessible. So Python code is written that executes SQL queries. So the database then returns back the data to the ORM, which returns it back to the model. It processes it and sends it to application layer. Then it goes to the controller, which renders the view, and then goes back to the user through a user response. And now the user is able to pull a report, say for example of all the sales that have been done for a specific period. So in the backend, this is actually what is happening. So as we continue, so models in Odoo are Python classes that represent and interact with database tables. They are built on Odoo's ORM, which we've just mentioned, the object relational mapping, a framework which simplifies database operations. So key features in the model, so they define fields, e.g. character, integer, boolean. These are the data types. They also handle relationships like one-to-many, many-to-one, many-to-many. They also automatically create and manage database tables, and they provide ORM methods for operations like the create, write, and link and search, which are also called the CRUD operations. So then next is the views. So views define the user interface for interacting with model data. They determine how users see and interact with forms, lists, dashboards, and more. So there are different types of views. So form views are used for detailed record management. For example, the sales order form. There is a tree view, or the list view. Also displays records in a tabular format like the sales order list. There is the Kanban view, which is a visual representation of records as cards. For example, the CRM leads. Calendar views display records with date-based data, for example the meetings or the calendar. Graph views represent data visually through charts or graphs, for example the sales analysis. Then there is the dashboard view, which aggregate key data for quick insights, for example the sales dashboard. Next are the controllers. So controllers manage requests and responses between the client, which is either through the browser or an API consumer, and the server. They are written in Python and typically handle custom web pages, APIs, or other custom behaviors. The key responsibilities of the controllers are to handle HTTP requests, e.g. the GET and the POST. They also return appropriate responses, e.g. HTML and the JSON. They also extend Odoo's default web interface with custom functionality. So as we continue, so the Odoo Addons directory is a core location where Odoo modules, both built-in and custom, reside. Each module follows a standard structure to ensure consistency and functionality. So when you first install Odoo Enterprise version 18 on Windows, there are two folders for add-ons created. One is in the server folder. The other one is in the server folder inside the Odoo folder called Addons. So the first add-ons folder is generally reserved for custom or third-party modules that are manually added by the developer. Though for our example, we recommend not using this folder, but creating your own folder, custom, and placing it at the server Odoo custom folder, which we have already done that. So this is a directory structure. So from the server folder, there is an add-ons folder that is created, this one, but we are not putting our custom folder here. We have created another directory inside Odoo, and this is where we have put our custom folder, which is our app called the Circle Management System. So the second folder contains Odoo's core modules, both community and enterprise editions, which are installed as part of the default Odoo installation. These modules form the foundation of functionality of Odoo and are maintained by the Odoo development team. So some special note here: you should not modify or place custom modules in this folder, as updates to Odoo could overwrite any changes or additions. Ensure the path to the custom folder is also added in the odoo.config file under add-ons path, which we have already done also. So if we go to the odoo.configuration file, we have added under the add-ons path this path to the custom folder. So when setting up the add-ons directory structure in Odoo ERP, it is essential to follow established naming conventions and best practices. These ensure consistency, maintainability, and compatibility with Odoo's framework. Odoo development adheres to the PEP 8 style guide, which is widely followed in Python development, including Odoo. So for the module, the naming best practices, so use lowercase and underscores for module names. For example, a module called Circle Management, so you put in lowercase and also you put underscores. Avoid spaces or special characters. So for unique module names, ensure the name is unique to avoid conflicts with existing or future modules. So say for example, it's best you put something like custom in front of CRM reports, assuming you are doing a module called CRM reports. In terms of the manifest best practices, so follow Odoo structure, which is the name, version, summary, sequence, description. We had covered this in the manifest file. So in the data list, arrange the files in the sequence in which Odoo loads these files. It begins with the security files, goes to data, views, reports, cron jobs, actions, and menus. So in our manifest file, so this is the order you should put your files. And we can also see this also in our add-ons folder. So say for example, we come here to Odoo add-ons, maybe we go to the accounts. So we can see here. So the data that is preloaded, they always start with security, then data, then views and such. So this is just best practices. Also, when you are naming the models files, which are Python files, so when creating the model files, create the file using singular names. Say, for example, maybe you have a model for a circle management system. So instead of members, you name it as member, or instead of loans, you name it as loan. Ensure the files have extension.py to denote their Python files. Imports should always go to the top of your model files, and for distinct modules, it should be on its own line unless you are importing files from one module. So say for example, maybe we look at the models files here. So say for example, we look at this account.account. So it always starts with the imports, and then now you proceed. After import, you skip two blank lines before declaring the class, while methods inside the class are spaced out with one blank line. So you'll always notice before you start declaring the class, you always skip two lines. We have also done the same in our custom module. So we begin with the import, and then we skipped two blank lines, and then we declared our class. So for custom modules, the class name should be named as app, then module name, e.g. Circle, which is our app, then member. So our model is member. So if you are doing, say for example, now you're doing a model for loan, you'll create the class name as a Circle loan to avoid name collisions. Class names should be in Pascal case, where the first letter of each word is capitalized. After declaring the class, what follows immediately are the class level attributes. These attributes will always start with underscores because they are part of Odoo's ORM framework and are not user-defined fields, e.g. name, description, inherit, SQL. So basically these are the attributes we're talking about. So all these are mapped to a column in the database, and through the ORM, now the system is able to know that this is the name and this is a description of that table. So when declaring a class, you need to use models.model, as all Odoo models inherit from the models.model base class, which provides the foundation for Odoo's object relational mapping. So basically, we are saying we declare the classes using this models.model. When it comes to the views, which are XML files, so the best practices for naming views start with the XML declaration that declares the encoding of UTF-8. Use correct Odoo view types. So Odoo offers different types of views such as form, tree, Kanban, calendar, and such. Always ensure that you're using the correct view type for the specific functionality you're working on. Use descriptive file names indicating their purpose, e.g. circle_member views.xml for views related to the circle members, or circle_menu.xml for menu definitions. Properly define fields in views. Ensure that the fields you want to display are correctly referenced in your views. Always check if the fields are present in the model and that their names match. Use XML property for layout. Odoo views allow layout and design features like group, notebook, page, field, etc. Be mindful of layout components to ensure that your views are user-friendly and responsive. So use views efficiently. Avoid excessive nesting of tags in views, which can lead to performance issues. Try to keep the view simple and avoid unnecessary complex structures. Also, always define security access for views. For each view, make sure you define appropriate security rules to ensure that users can access or modify the data as required. This can be done using the ir model.access CSV file in the security folder. So also avoid hard coding field names. While this is not always possible, try to avoid hard coding field names. Ensure consistent indentation. So say for example, if you were to look at our views, we don't have so many, but say for example, let's look at the ones that are here in the standard code. So you see this kind of indentation where actually it is maintaining 4 spaces as part of the PEP 8 we talked about. So this one you can always ensure it's the spacing here is 4, and in case it's not 4, you can always ensure it's configured that is the tab size. Okay, so ensure consistent indentation. Also consider the model's access rights when creating a view. Make sure that the proper access rights and rules are set up for the underlying model. Test views thoroughly. Use Odoo's built-in widgets and controls. Consider mobile and tablet users. So when designing forms or other views, try to consider how they will render on mobile or tablet devices. Avoid overly complex or large elements that might not look good on smaller screens. Concerning views, backend views should be split like models and suffixed. We are continuing. So for the security directory, which is usually CSV files, so these are the best practices. For access control lists, usually named like ir.model.access.csv, should follow this format, where you can see the IR model, the ID, the name, the model, all this. So if we look at our security folder, so we have already declared our access in the security. So use descriptive IDs and names. Ensure the ID and names are descriptive. Define group specific access. Restrict permissions by default. Use record rules for fine-grained control. Use groups attributes in views and fields. Separate security files by type. So say for example you have files for the access control list and the security, so you can separate them. Follow the principle of least privilege, so grant users the minimum permissions required for their role. Avoid granting permission create or permission unlink unless strictly necessary. Test the security rules, and also use custom security groups. So define custom security groups for your model instead of relying only on Odoo's default groups. For the data directory, which is also has XML files, so best practices for this is so in Odoo development, the data folder and its XML files play a crucial role in defining pre-configured data or initial or static data. So start with the XML declaration, which is also encoding of UTF-8. Use descriptive file names, organize files logically, declare records with unique external IDs, avoid hard coding IDs, use priority loading. So load XML files in the correct order via the data section of the manifest file. So you can load the security files as I mentioned, and then you can load the default settings and the templates. Comment for clarity. So add comments explaining the complex records for future maintainers. So the way you add these comments, let's just look at one of these. So if I look here under data, so you can see here the way the code has been commented. So we can see this is for the partner trust property. Let's look at another one. Okay. Yeah, so these are the comments you put, like for example, we can see here this is a comment for payment methods, so we know all this code here is related to the data that is preloaded for payment methods. So avoid overloading the data folder, only include essential records in the data folder, use demo files for sample or testing data, avoid updating core data, avoid modifying core or Odoo records directly, instead create extensions or overrides when needed. Test the XML for errors. So the static folder, best practices. So in Odoo development, the static folder is used to store static assets such as images, JavaScript. So best practice is to organize files into subdirectories. So you can have a directory for the SRC, the source, the description, the documents. Use descriptive files and folder names. Optimize image files. Use CSS for styling. Use SCSS for styling, which is the SASE cascading style sheets, because it allows modular styles. Minify CSS and JavaScript files, and also include module-specific static assets only. We are continuing also with best practices on the static directory. So reference static assets dynamically. Maintain a clear description folder, for example, for your images. Avoid hard coding paths. Test cross-browser compatibility. Avoid conflicting asset names, and use the doc folder for documentation. I'd already mentioned about the sizes of the logo. So say for example, if we look at the icon for the sales module, this one here, if we were to go to the system, it's installed in server Odoo Addons sales static description. This is the icon. You can see if we look at its size is 100 pixels by 100 pixels. Okay, so now we are going to the next subtopic, the database structure and the ORM layer. Introduction to Odoo database and ORM. So Odoo runs on PostgreSQL. Features of the PostgreSQL database. So transactional support, data integrity, scalability, and extensibility. Just as a quick note here, PostgreSQL supports up to 32 terabytes of data. So as much as no matter how many transactions you have on Odoo, the database is quite scalable. So when installing on Windows, Odoo automatically installs PostgreSQL unless there's another previous version running. So the role of the PostgreSQL is to store the business data and all the other data. So how the ORM abstracts the data. So it, as mentioned, it creates Python objects that connect to the database through SQL queries. Benefits of Odoo's ORM: it simplifies the development. No need to write SQL queries for standard operations. It ensures consistency, automatically enforces data integrity and relationships. It enhances productivity. So key features of the Odoo ORM: so there's the model mapping, maps Python classes through the models.model PostgreSQL tables. Field mapping: it maps class attributes to database columns. We talked about these attributes. Relational management: it handles relationships one-to-many, many-to-one, many-to-many automatically. Now we can continue. I think we had covered this. Okay. Now, once we go to the key model attributes, okay, so the attributes for the ORM. So, for example, there is the name. This defines the internal name of the model. This name is used as the database table name. There is a description also, provides a human readable description. There is order, specifies the default ordering of records when retrieved from the database. So, say for example, in ascending or descending order. There is a record name. This indicates the field used to display record's name in views. Inherit: it is used to extend an existing model instead of creating a new one, e.g. inherit of the rest.partner. We can see a lot of this inheritance. Say for example, maybe we come to the one for sales. Let's just look at the sales app. Then we go to some models. So we can see, like here, it's inheriting from the account.move line. So you'll see a lot of these attributes after declaration of the class. SQL constraints: so defines SQL level constraints for the model. For example, if you want to ensure that a specific field, let's say email, must be unique, and also log access, so controls whether to include standard logging, the fields to be captured in the log file. Okay, so we are continuing to the field types and attributes. So as we mentioned, Odoo has several field types. Say for example, the character, the text, the integer, the float, the boolean, the date time. There is a selection, and then there is a relation of fields. So I'll just mention a bit on this relation of fields. So for example, the many-to-one, this is used when each record in the current model is associated with exactly one record in another model, e.g. each sales order has one customer. So in the model for the sales order, the customer field in that sales order is a many-to-one, which you can just have a look at. So just ensure. Okay, so if I come here to sales and then I come to orders, so the customer field here, you can see here the field type is a many-to-one. So basically it means that each sales order has one customer, despite that you are choosing on that one customer from a table of customers, several customers. So for the one-to-many, this is used when a record in the current model has multiple related records in another model, e.g. the customer has multiple sales orders. So in the customer table, for a customer who has several sales orders, the sales order ID will be a one-to-many field. For the many-to-many, this is used when records in both models can be linked to multiple records in another model, e.g. products can belong to multiple categories and categories can contain multiple products. Also, other common fields are the binary and the HTML. So using fields attributes, so fields also have attributes. For example, you can use an attribute like required. So if we look at, so you can see all these fields here. Okay. So you can see like this attribute here, read only. We can see we have a default here, we have one for tracking here. So required default read only index. So index adds a database index to the field for faster searches, e.g. email. You can also have an attribute, a field attribute for help, for string, for size to limit the characters in that field. Say for example this one is limiting to 10. Related, this links a field to another field in a related model. Store indicates whether computed fields should be stored in the database, and compute also. So relationship between models, I think we've covered this relation of fields, the many-to-one, the one-to-many, and the many-to-many. So best practices for relation of fields: use meaningful field names, optimize relationships, secure relational data, and use foreign keys. Okay, so we are proceeding. So these are the ORM methods for CRUD operations, that is create, write, unlink, read, browse, and copy. I won't go so much into details for this, but basically you need to, or rather the ORM method is able to use these CRUD operations when modifying data in the database. So best practices for using ORM methods. So validate data, perform data validation before create or write to avoid database integrity issues. Optimize the search, use domains efficiently, and limit results when appropriate to avoid performance bottlenecks. Use try except blocks, avoid hard coding IDs, use record sets, log important changes, and such. So there's also constraints and validation in Odoo. So we talked about the SQL constraints. For example, email has to be unique, and also you can have also what we call so when to use the SQL constraints: uniqueness, when you need to ensure that a field's value is unique across the table, e.g. email addresses; check conditions when you need the database to validate specific conditions; foreign key relationships to enforce referential integrity between tables. That's when you use SQL constraints. You can also use Python constraints with API. So key features of Python constraints: they allow you to write complex validation logic using Python. They can check the value of multiple fields. When to use Python constraints: so when the logic is complex, when you need to validate more than one field or use complex business logic. Custom validation: so when you need to create custom validation rules that go beyond what SQL constraints can handle, e.g. multiple fields, data comparisons. Dynamic validations: when the validation depends on values that may change based on certain conditions. So what are the best practices for using constraints in Odoo? So use SQL constraints for simple, performance critical validations like unique constraints or check conditions that can be enforced at the database level. When do you use the Python constraints? Use Python constraints for more complex business logic, or when validation depends on multiple feeds or external conditions. Combine both SQL and Python constraints for comprehensive validation. Always raise a validation error in Python constraints when a validation fails, as this will stop the safe process, and notify the user with a meaningful error message. So when defining constraints, ensure that they are clear and understandable, as they help maintain the integrity of your Odoo application. So these are debugging and optimizing of ORM queries. These ones we'll do them practically in our next series. Key configuration files in Odoo. Okay. Okay, so the request and the responses, we covered this in that workflow for the MVC. Okay, we can go through an overview of the workflow. So below is a general flow of a request in Odoo. So user interaction. So a user performs an action, e.g. clicking a button, submitting a form on the front end, that is the web browser or mobile app. So a user clicks create member in the circle management module. So a HTTP request. So the action generates a HTTP request sent to the Odoo server using the WAGZAG framework. Then routing happens. Odoo's routing mechanism matches the request to a specific controller method based on predefined routes. The create member URL maps to the corresponding Python method in the controller file. Controller processing. So the controller receives the request and interacts with the model to execute the desired operation. E.g., the controller calls the create method on the circle.member model to add a new record. The model, okay, next is the ORM and the database interaction. So the model method processes the request using Odoo's ORM to interact with the database. A new member record is created in the circle member table in PostgreSQL. Response generation. So the controller generates a response, e.g., a success message or updated view based on the operations result. User feedback. So the response is sent back to the user browser, updating the UI with the requested data or action result, e.g., the user sees the newly created member in the list view. Okay, so we've gone through this workflow. These ones we'll cover them in the API integrations. So that concludes our video for today. We have been able to go through understanding Odoo architecture, and we look forward to continuing with our series. Thank you for taking the time to watch this video. We welcome any questions or suggestions, so feel free to contact us at sales@softiqtechnologies.co.ke, and if you can subscribe and like our page, we will appreciate. Thank you.